What is a petrol engine? Its application, parts, and how it works. A petrol engine is a spark-ignited internal combustion engine rather than the compression-ignited systems used in diesel vehicles. In the spark-ignited system, the fuel is injected into the combustion chamber and combined with air. A spark from the spark plug ignites the air-fuel mixture. In this video, we'll explore what a petrol engine is, its diagrams, application, parts, types, and how it works. What is a petrol engine? A petrol engine is a type of internal combustion engine with spark ignition, spark plug, which uses petrol and similar volatile fuels to run the engine. The earlier petrol engine was designed to pre-mix fuel and air before compressing, which occurs in the carburetor. However, today's fuel injection is electronic controlled. A two-stroke petrol engine is a type of internal combustion engine that completes a power cycle with two strokes of the piston during only one crankshaft revolution using petrol-air mixture. This is in contrast to a four-stroke petrol engine that requires four strokes of the piston to complete a power cycle during two crankshaft revolutions. Applications of a petrol engine. Petrol engines are widely used in different fields where it has become inevitable for humans to use them due to their distinctive service. The applications of petrol engines include automobiles, motorcycles, aircraft, and motorboats. Also, small engines, such as lawn mowers, chainsaws, and portable engine generators. Today, four-stroke gasoline engines are generally used in the automobile sector and vehicles. It is used in petrol cars, scooters, small motor-powered boats, motorbikes, small propeller aircraft, water spray systems, etc. These engines have been highly applicable to the higher value of the low punch end capability of the engines. The application of a two-stroke or two-cycle petrol engine is an internal combustion engine that is often found in smaller, lower-power engines such as scooters, dirt bikes, jet skis, smaller outboard motors, and lawn equipment such as lawn mowers and chainsaws. Parts of a petrol engine. The various parts of a petrol engine include 1. Cylinder. These engine parts are located in the engine block, also known as the cylinder block. It contains a liner or sleeves around it. This liner wears out when subjected to work and can be easily replaced. The cylinders have part or space for the piston to move upward and downward, making the combustion take place. 2. Piston. The piston is a cylindrical part that moves upward and downward in the cylinder, allowing the complete combustion cycle to take place: intake, compression, combustion, and exhaust. Check out how this process works below. The diameter of the piston is a bit less than the bore of the cylinder to avoid quick wear of the piston surface. There are 3 rings, known as piston rings, fitted in the circular recesses on the piston surfaces. These rings are made of aluminum and have direct contact with the cylinder liner, thus preventing piston wear. 3. Crankshaft. These engine parts help to convert the sliding motion from the piston into rotary motion via the connecting rod. It is located below the cylinder block inside a casing called the crankcase. The crankshaft has projections bent and offset from the shaft axis. In a multi-cylinder engine, each cylinder is provided with its own crankpin, which is used to attach the piston to the connecting rod. A part of the crankshaft named crankpin journal bearing is known as a big end, having a sliding bearing. 4. Connecting rod. These engine parts are provided to connect the piston to the crankshaft. Just as mentioned earlier, it converts the linear motion of the piston into the rotary motion of the crank. One of its end parts is attached to the piston through a piston pin, also known as a gudgeon pin, and a wrist pin. Another end is attached to the crankpin journal using bolts to hold down the upper and lower bearing caps, called the big end. 5. Cylinder head. These engine parts serve as a cover for the cylinder block, valve, rocker arms, and ignition element. It is bolted to the cylinder block with the head gasket in between. The cylinder head is made from cast iron and sometimes aluminum alloy when a lightweight part is needed, as aluminum conducts heat more quickly than cast iron. 6. Camshaft. This internal combustion petrol engine component is a shaft containing a cam fitted on it. Its function is to control the valves directly by sitting over them or through the rocker arm and pushrod mechanism. The valve timing is determined by the size of the camshaft. That is, the opening and closing of valves are governed by the camshaft, which is mounted on the crankshaft either directly through a reduction gear or indirectly through a pulley and a timing belt. 7. Valves. Valves, also known as poppet valves on IC engines. It is made of a long, thin circular rod called a valve stem and a flat circular disc called a valve head, which is tapered along the thin rod. The function of the valve is to enable a fresh intake of fuel and air and the release of waste gases, exhaust. The sliding motion of the camshaft and its associated linkages is what causes the valve to open and close. 8. Rocker arm. This internal combustion engine part plays an important role as it transmits the rotary motion of the cam or crankshaft through a tappet latch and converts it into a linear motion of the valve stem, helping to depressing the valve head. 9. Crankcase. These internal combustion engine components are located below the cylinder block containing the bearings that rotate the crank. This main bearing is a sliding bearing with an adequate oil supply in it. 4-cylinder inline petrol engines contain 3 bearings in the crankcase, 1 at each end and 1 in the middle, while diesel engines have 5 main bearings, 1 at each end and 1 between each cylinder. 10. Oil pump and sump. The function of the oil pump is to pump the oil to various parts of the engine for proper lubrication, cleaning, and cooling. The crankshaft gear in the engine is what drives the oil pump. The oil is pressurized to various parts of the engine components, which helps in lubricating and cooling the system. Types of petrol engine. Petrol engines are classified by configuration, cycle, and ignition method. Here are the main types of petrol engines based on the stroke cycle. 2-stroke petrol engine. In 2-stroke types of petrol engine, the compression and power stroke of the 4-stroke cycle are carried out within the inlet and exhaust strokes. This makes it require just 1 revolution of the crankshaft to complete the cycle. 4-stroke petrol engine. The 4-stroke petrol engine that requires 4 strokes of the piston to complete a power cycle during 2 crankshaft revolutions. They are used in petrol cars, scooters, small motor-powered boats, motorbikes, small propeller aircraft, water spray systems, etc. Learn about 4-stroke engine here. How petrol engine works. Due to lower compression ratios and the fact that gasoline burns more quickly than diesel, gasoline engines rotate at higher rotation speeds than diesel engines. Because pistons in gasoline engines tend to have much shorter strokes than pistons in diesel engines, it typically takes less time for a piston in a petrol engine to complete its stroke than a piston in a diesel engine. However, the lower compression ratios of gasoline engines give them lower efficiency than diesel engines. Typically, most gasoline engines have approximately 20% average thermal efficiency, which is nearly half of the diesel engines. Advantages. The following are the advantages of petrol engines. Petrol engines are generally more powerful, by way of horsepower, than diesel. Petrol engines naturally benefit from being easier to tune. It has a better ratio of price to power and burns fuel more eco-friendly than diesel does. Petrol is usually cheaper than diesel fuel. Disadvantages. The following are the drawbacks of a petrol engine. Generally, the petrol engine's lifespan is almost always shorter than that of the diesel. Diesel engines usually have a higher residual, resale, value. Petrol engines get fewer miles per gallon, sometimes significantly, than their diesel counterparts.